SC, internal control. You have to explain in the previous section and all these things. So triple SC is actually based on a synchronous voltage source concept, which is implemented by VSC. First point. So that's introductory. Then from the above fact, we can have is the voltage, output voltage can be controlled either by directly or by indirect method. So direct method and indirect method, two methods are there. And in case of direct control method, what you have, both angular position and the magnitude of the output voltage are controlled, whereas for indirect only angular position is controllable. Okay, so that whereas for indirect control only angular position is controllable, but magnitude remains the same, means it is directly proportional to the DC terminal voltage. That you have to keep in mind. Okay, so directly both angular as well as magnitude of the voltage is controlled, whereas in indirect method only angular position of the voltage is controlled. Then another point you have is method of controlling, maintaining the quadrature relationship, means the voltage and current will lag behind one another by 90 degrees. So angle between voltage and current is 90 degrees to provide the reactive series compensation and handle the subsynchronous resonance. So this is two methods. So because of this requirement, we usually go for indirect control converter so that it can provide reactive series compensation and handle SSR, subsynchronous resonance. Okay, so this is the reason why we go for indirect control method. So then for direct control, what you require is single frequency or the fundamental frequency output independent of DC terminal voltage requires a directly controlled converter. So if the requirement is this output, if the requirement is maintaining single frequency, then you go for direct control. Whereas if you require for controlling the subsynchronous resonance and all these things, then we go for the indirect method. Okay, so methods depending upon that, we go for that. Then just you can see, although the high power is directly controlled converter are more difficult and costly to implement than indirectly controlled converter. However, we can have is we can realize the practical utility requirement, and indeed they are used along with indirectly controlled converter. So directly is this in existing installation for transmission compensation. Okay, so why high power direct control converters are more difficult compared to indirect control converter? However, they can be used in collaboration with indirect control converter in this present existing transmission compensation. So now internal control scheme for indirectly control triple SC. So internal is shown in this figure. So this is this. So same thing, triple SC. You can see here the input you can have. So this is the functional block diagram. This part is the control part. Actually, this much is the control part, and this is your line part. So this is your triple SC. So triple SC is this. Okay, so this part is triple. So converter, you have then line, all these things. So it is injecting VQ, the injection or the voltage, quadrature voltage injected by the VSC, voltage source devices. The input to the internal controls are, what could be the internal input here? Any idea? Dojgetsin came. Samjana is not there, no? Hello? Hello? Dojgetsin?
Yes,
Hello?
sir.
Okay, can you tell the inputs? So like it is same. So what are the inputs here? Input. Cheongdoji? Hello.
Sir, I just came now, sir.
Okay. So any idea, Gaki? The inputs to internal control are Kachkachong. Okay, line current, I. Then Gaki, one more. VQ. Then any other? Karmawangdi? VQ, REF. Kezang, can you tell?
Reference voltage, sir. Reference voltage.
VREF, okay.
VQ is.
VQRF, okay. Then, okay, so this is your line current. So first input is line current. Then second one is injected compensating voltage, this VQ. And third one is, I think, VQ reference VQ. Okay, so these are the input to the internal control. Then what you are doing, so you can, then the control of this one actually is synchronized to the line current. Okay, so the control of this is actually synchronized with line current, this line current, by a phase lock loop. So by this phase lock loop, this one. So it is synchronized by this phase lock loop, after which between this cycle pi by 2 or minus pi by 2 phase shift provides the basic synchronizing signal theta. So up between this, so this is what we have. So first line current is given here to the phase lock loop. Then this phase lock loop will, what it will do is it will synchronize it, and then phase shifter plus or minus pi by 2, and then after that it will generate this signal theta. This is synchronizing signal theta is there. Then the phase shifter is operated from the output of polarity detector. So this phase shifter, so polarity detector, it is given. So what it will is, the supply to the polarity detector is given from the voltage reference section, and then it will operate. And then polarity detector, if it is positive, it will give it to the positive direction. If it is negative, it will give it to negative direction. Okay, so this is what we have. Detector which determines whether reference is positive, capacitive, or negative, inductive. So this is what it will be. So positive bewatching, capacitive, negative bewatching, inductive. So this. Then another one, the compensating voltage VQ is controlled by, this VQ is controlled by simple closed loop. So it is controlled over here, simple closed loop. So now the absolute, this ABS is actually absolute converter. So it will, this VREF will be converted to absolute number, means magnitude. It is magnitude there. Okay, so magnitude wise it is there, magnitude, and the absolute value of reference VQ. So this absolute VQ is fed to that absolute converter, and then at that absolute converter it will convert to this one. So this VREF is converted into the magnitude, and then this VQ, the compensating injecting voltage, after going through this voltage magnitude computer will be compared with VQ reference here, and the error of this is given to the error amplifier. So this, after the output of error amplifier will be del alpha. So this del alpha, again it is sum with this signal amplifier, and that signal, this finally this signal is fed to the gate, and this output of that gate pattern logic is given to the gate of the converter, and hence the gate of the converter is fired, and then accordingly this triple SC will operate. So if you want to inject it, you have to control in such a way that the voltage will be greater than the line voltage. If you want to absorb it, you have to control in such a way that whatever is there, it should be less than this. Okay, so this is what it is actually having here. So look, the absolute value of the reference VQ is compared to the measured magnitude of the injected voltage VQ and amplified difference, that is error, is added. Okay, so here this is the internal, so similar to that of what we have done in that STATCOM and all this thing. Then depending upon the polarity of del alpha, okay, angle theta, and consequently the converter gate drive signals will be advanced or retarded, and thereby the compensating voltage VQ will be shifted with respect to the prevailing line current from its original pi by 2 or minus phase shift. Depending upon this, then there will be either absorption or the generation of reactive power. Okay, so here now you have is the phase shift will cause the converter to absorb real power from the AC system for the DC capacitor or vice versa. Supply that to the supply system from DC capacitor. Okay, so this is what it will happen to the internal control partner. So now what happens? A result of this is, as a result, the voltage of DC capacitor will increase or decrease, causing a corresponding change in the magnitude of compensating voltage. So this will change depending upon this. If the DC capacitor voltage increases, here the phase shift will cause converter to absorb real power from AC system for the DC capacitor. It will absorb, or vice versa, means it will supply to the AC system from the DC capacitor. Okay, that is, it is there, so vice versa. So now if it is absorbing, what will happen? If it is absorbing, the voltage of DC capacitor will increase. If it is supplying, then it will decrease, so causing a corresponding change in the magnitude. If it is absorbing, so VQ will increase. If it is supplying, VQ will decrease. So depending upon that, this compensating voltage will also change. Okay, so that's what we have for control key, internal control. Then for direct control, we have this. So direct nadi, we have different here. Again, now for direct control, we have to maintain the voltage. So we are giving a DC. So extra, this is additional internal. So compared to internal, we have this. This is the extra. So this scheme can be used to eliminate the unwanted output voltage components due to the modulation of DC capacitor voltage by subsynchronous or other line current components. So this type of, you have that. Then direct control is also suitable to provide both reactive and real line compensation if the converter is equipped with the suitable power source. Okay, so that is this. So if this type of is required or suitable only for the control of both active and reactive power, if the device is equipped with this supply, DC supply. So the SSC will be able to supply the real power with the transmission line only if they are equipped with this DC supply. Okay, so this direct control is required only if you want to control or compensate the real power. So here now the control structure is similar, except for the cases it has got continuous and independent control of the both magnitude and angle of the compensating voltage. So it's they are independent to one another. So here same thing, the synchronization of line current is provided by this. So you have polarity detector, then it is given, then VQ, all these things are given. So what we have discussed, same thing we have discussed in that STATCOM, control of STATCOM, control of that shunt converter and all this thing, we have done same thing. The function remains same here. Okay, only thing here, VQQ reference is just converted to absolute number, and then it is converted from here. Q compared and then given to array element. Then VDC and VDC reference compared, and that is fed to the array. Output of that one is given to the comparator, and then VQ reference. This real component of this one is real component of the reactive voltage is compared with the output of this DC, and then it will amplify, and then it will, so this magnitude and angle computer generator will generate two things. One is angle phi and another one is this voltage V. Then this angle phi is added with the output of this PLN, and then this signal is actually supplied to the gate logic pattern, and then output of this GPL is given to the gate of the converter, and then gate is actually fired, and hence this converter will operate. Okay, so this is what actually you have. Same thing, nothing new here. Okay, so now you can just see in this, just you can go through it as just a summary of the above control stages, direct and indirect. And now another thing you have is the external control circuit for series reactive compensators. Okay, so this is your external control circuit for this. So it can be controlled VQ reference, then power oscillation damping, then SSR, transient stability. So external you can control all this. Okay, so you can just go through, nothing new here. Okay, so this is what you, so external control nadi, the advantage or the added features here in external control is this. So other than this VQ reference and all these things, so you can put this switch up there, you will be able to do the power isolation damping, you will be able to have this SSR damping, and you will be able to do that transient stability also. So these are the added feature of external control compared to the internal control. Okay, so you have this mode selection, so you can use this mode, you can keep this, you can use this. Okay, so these are the topics. So with this we have completed the triple SCG also. Did Samjana came? Yes, Samjana there. Okay. So anything to share? So we have only this much for today's class, UPFC. Now next class we will start with UPFC, another topic for that. That is now, see now with this, we have completed the shunt compensation, we have completed the series compensators, like types of series compensator, types of shunt compensator, we have completed. Now next type you have is, what you have, types of FX devices, we have different types of FX devices, anyone? Hello, Gaki, different types of FX devices. Different types of FX devices, anyone?
Series shunt and series controller, combined series shunt controller.
So you have a series, shunt, and then combination of two. Right, so combination. So now we have completed with shunt, we have completed with series. Now next topic for discussion is we have for this combination of that two. So the combination of that two, example, any example you have? So IPFC and UPFC you have, so we'll be discussing that too. IPFC and UPFC is there. Okay, so next topic we'll discuss that too. Samjana is having any network problem. Natujam now again gone. class test this big other modules they have done class test.
Tatu Mabe sir.
Kage mabe.
Mabe sir. Nava Byung Sachi.
Kachigi.
Power system.
Controlling operations sir.
Operation and control ki.
Yes sir.
Okay. So online baby, you can see how it is there. Then we will try to implement it.
Yes sir.
Tadu gatan di pecha.
Try with us, sir.
Actually, Tatula, sir.
Ah,
Sirita practical man should be over sir and practical ye hamchi be sir.
kachigi lo.
Microcontroller ki practical sir.
Oh. Tata ko bon achiri pecha mata otama.
Sirita to sir.
La big of sir. La, sir.
La kachila bende.
Po, sir.
La dan beni me onde wala.
Sir mapule bego sir iko bego formula be dero ran be bichabe achi turam bero bego sir.
Dan chesu di da overburden im debu.
Phase test yoga, sir.
Face test di da tu leshomchi decide bema chu gale ben na dan CSC dan be ben na mabin na mashe will see daru and discuss that with the department na meeting e mabe. As of now the yet bera ye they will the mashe de gari bin na. Tit ka belo and be but keep studying, that's all. Bottom line.
Tubla, sir.
Sir.
Ama ye se watching then you have to do that. Me se watching there's no loss, no?
Yes sir.
Meru the knowledge will not be gone, but he is watching then you can't study overnight. Ani cham
Semester end get into the sir. Tasha.
semester end the online maybe no?
Men sir. Look slip biome sir.
Oh. Andi benyong pen study. Okay, so thank you. Next.
Thank you, sir.
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 Okay.